So, what is a hydraulic jump? Hydraulic jump is a phenomenon in hydraulic that is generally reported in open channel flow such as a river and spillways. When a high velocity liquid discharges into a zone of lower velocity, the liquid surface rises abruptly. The strength of the jump depends on the Froude number of the flow entering the jump. Froude numbers represent the influence of non-uniform flow velocity on open channel where supercritical flow is obtained at Froude number greater than 1, where subcritical flow is shown at Froude number less than 1. The experiment is usually conducted in an open channel such as a flume, where water flow over a fixed bed. The flow rate is typically controlled by adjusting the inflow rate or by using a weir or a sluice gate. The water depth, turbulence, and other flow properties are then measured at various points along the channel, including to the jump point. The data collected during the experiment is analyzed to understand the physics of the hydraulic jump and its effect on downstream erosion and sedimentation. So, objective for this mini project, which is number first, to determine the relationship between the flow rate, initial and final water depth and jump length. And another one, to visualize the phenomena of hydraulic jump in a rectangular film.
Hydraulic jump is a phenomenon that occurs when a liquid such as water flows over a smooth surface and suddenly increases in depth. This increase in depth causes an abrupt change in the velocity of the fluid and result in the turbulent flow pattern. In a laboratory setting, an experiment may be conducted to study the hydraulic jump and measure various parameters such as the flow rate, depth of the jump, the energy loss, and Froude number obtained to associate with the jump. The problem statement for such an experiment would be to understand the physical principle governing the hydraulic jump and to measure the relevant parameters in a controlled laboratory setting.
The apparatus for a hydraulic jump typically using a tank or flume to hold the water, a pump to provide a constant flow of water, and a sloping surface of weir, a barrier that controls the flow of water to create the jump. Some apparatus may also include measurement device such as deep gauge or a flow meter to collect data on the water velocity and depth. The apparatus may also include a system to regulate the flow such as a valve to allow for a more controlled experiment. This is the equipment that we have been using in the experiment, including a stopwatch to measure the time, a ruler to take measurement, and tailgate to block the flow of water and create a hydraulic jump.
The first step is turn on the machine switch. After that, adjust the position of the sluice gate in the correct state. Then place the tablet on the end of flume. Then open the valve to release the water. After the water has come out, we measure the width of flume. After the water is stable, we measure the height of the sluice gate. Then we measure the height of Y. After that, the height of Y1 is measured before the water jumps. And the height of Y2 after the water jumps is also measured. The distance is also measured between water jumps until the water is in a stable state. After everything is measured, we record the flow rate and record the time. All the step and measure repeated in the 3 times. Assalamualaikum. I will explain about data and calculation. So the data that we get from this experiment, width of the flume that we measure is 9 cm, and the height of tailgate that we measure is 1.9, and the volume 2500 millimeters. This volume is constant for 3 tests. So this time we take time for the 3 tests and we measure H1, H2. After that we go to the calculation. The calculation, firstly we find the V1 and V2. Before we calculate the V1 and V2, we need to find the discharge. So this first discharge for test 1 and this V1 and V2. After we find V1 and V2, we find the Froude numbers. So this is a formula of the Froude numbers. From formula, we put the data from V1 and V2 in formula, then we get F1 and also the F2. After we find the Froude numbers, we go to find the energy loss. So this is a formula for energy loss. So the test 1 is E1 0.031 and E2 0.044. After we find E1 and E2, we find the energy loss. That is the formula E1 minus E2. So that's all.
In conclusion, hydraulic jump experiments are crucial tool for learning the physics of the physical processes known as a hydraulic jump, which happen when a liquid like a water flow over a fixed bed. Students can learn about hydraulic jump from the result of this experiment, and the information gained from it can be used to design wires and spillways that are more effective and efficient hydraulic structures, as well as to better understand and control important environmental flow in the river and natural channels.